Hello Algebra 2. This video lesson is designed to help you prepare for the quiz that's coming up on Chapter 6.4, which is all about actually factoring as well as solving polynomials. The list here, written by a different teacher than myself, says quadratics, cubics, and quartics. So you're going to need for that quiz to be able to factor them and to solve them. I've already given you this guide and the answer key as well. Both of these are posted on my website. So you may not need to watch this video. All I'm going to do in this video is walk you through those answers and explain them as best I can. You still may want to watch this video later though when it comes time to review for the test on all of Chapter 6 and certainly at the end of the year when it comes time to review Chapter 6 for the final exam. Okay, first question that you were given on the document that I handed out was this one, and it tells you off to the left here. By the way, I won't do that on the quiz. I won't tell you that this is a GCF type of problem, but it tells you this is a GCF type of situation, and they're asking you to factor it. So that you're looking for common factors between 6x squared and 3x. Well, both of them can be divided by 3, and both of them have x in them. So you pull both those things out. Oops, trying my best to pull that down. And you end up with this, 3x times 2x plus 1. And that's it. That's factored. How do you know that you're done? Well, 3x certainly can't be factored any farther. And 2x plus 1, they don't have anything in common. There aren't any rules that you have for breaking 2x plus 1 down any farther, so that's as far as you can go. Now, carrying that to the next step, over here you're supposed to solve the same question. So, if you were given 6x squared plus 3x equals 0 and asked to solve, then what you're trying to do is figure out what x is. So this is no longer the final answer. I'm going to assume this work over here and just pull this answer over to here, and you've got to go that next step. You know that it's 3x times 2x plus 1 equals 0 because all of that work was already done over here. Now you got to find out what x is. Well, in order for this to be equal to 0, then either 3x had to be 0 or 2x plus 1 had to be 0. If 3x were 0, again, I'm having trouble pulling this down. If 3x were 0, that would mean, oh, here, this is just restating what I just said. If 3x were 0, that would mean x would have to be 0. And if 2x plus 1 were 0, that would mean 2x would have to be negative 1. And then x dividing by 2 would become equal to negative 1 over 2, or in other words, negative 1/2. And so those are your two answers there. X is either 0 or negative 1/2. Moving on to the next example. Remember, DOTS, or dots, stands for difference of two squares. So the author is telling you that both of these are perfect squares, and they are. 25 is 5 squared. X squared, of course, is the square root of that is x, and the square root of 9 is 3. And remember your rule for difference of two squares, and that is that you have the square roots left and right in a binomial and a matching binomial, but the first one has a minus sign dividing the two terms. The right one has a plus sign. So it's 5x minus 3 times 5x plus 3. And that's finished. If you were asked to solve this as an equation, then you would have already figured out, just like I did on the left, that those two binomials were equal to 0. In order for them to be equal to 0, then either 5x minus 3 is 0 or 5x plus 3 is 0. If the left is true, then x has to be 3/5. And if the right is true, then x has to be negative 3/5. So those are the two answers, the two possible answers for that question. Third example, trinomial square is the name for this situation here, where this left term is a perfect square, the right term is a perfect square, and the middle term is the square root of this, in other words 3x, times the square root of this, 2, so 3x times 2 is 6x, doubled. So that's 12x. When that's true, we had a rule about that, you might remember, which said that as a shortcut, this factored is that square root minus that square root, in parens, squared. And the reason this middle value here is a minus is because that was a minus. If that had been a plus, that would have been a plus. So if you know on the left that 3x minus 2 squared is the factor, then 3x minus 2 squared is going to be equal to 0, just as that is equal to 0. If 3x minus 2 squared is equal to 0, you can take the square roots of both sides. That means 3x minus 2 must be equal to 0. Move the 2 over, divide it by 3, and you're going to find that x is 2/3. Remember what I said here about this being a minus, therefore that being a minus. Here's the, I'm sorry, never mind. I thought number 4 was a different problem than it is. This is a break the combination question, and the author called it break the combination. I've been teaching you all year to call it cross them up and split the middle. Either way, it means the same thing. You put 2 times -3, or in other words, -6 at the top, this middle coefficient 1 at the bottom, and you'll find that 3 times -2 does multiply to make -6 and add to make 1. So bring the 2x squared down and the -3 down, but break that middle term. And you've got 2x squared plus 3x minus 2x minus the 3. Split it down the middle, factor the left and the right, and you should end up with x minus 1 times 2x plus 3. In the interest of time, I'm speeding up a little bit here on the ones on page 1, which are review. So on the right, I've got this same question now, but set equal to 0. So I've got that same result here, x minus 1 times 2x plus 3 equal to 0. If the left is true, if it can either be x minus 1 is 0, or it could be 2x plus 3 is 0. If the left is true, x must have been 1. If 2x plus 3 were equal to 0, then x must be equal to -3/2. Now, moving on to page 2 of the document that I gave you. And notice this hint they've given you. Don't forget the quadratic formula. Again, the quadratic formula can only be used for solving, though. So this could be a little bit misleading. If a quadratic can't be factored, then that's the end. It can't be factored on the left. On the right, though, you could still try the quadratic formula. All right, well, x cubed plus 1. Actually, what I have here is a perfect cube on the left and a perfect cube on the right, as this type nicely gives away to us. When that's true, remember the pattern that you have. You've got effectively x plus 1 as a binomial on the left, so cube root of that is x, cube root of 1 is 1, and on the right you got a trinomial. It's going to be that squared, so x squared, and on the right it's going to be that squared, so 1 squared is still 1, and this middle term is going to be that times that, or 1x, or in other words just x. And then remember, when it's sum of two cubes, the only minus sign that you're allowed is at the very middle, and it's between the first and second terms of the trinomial. That's factored. On the right, you take those factors, set them equal to 0, because now you're asked to solve. That means either x plus 1 is 0, or the trinomial is. If x plus 1 is 0, x is -1. On the right, you've got a lot more work to do. X squared minus x plus 1 equals 0. Well, you're going to find, if you try, that that can't be factored. Well, like I said up here, if it can't be factored, try the quadratic formula. That's what they did. And this would have been a perfectly satisfactory answer to me here. 1 plus or minus I root 3 over 2. The author has written this as two separate answers, the plus and the minus. I don't care about that one way or the other. This is perfectly fine. I would know that that's two different answers. So you've actually got three, x equals -1 or x equals those two possibilities. Looking at the difference of two cubes, works very similarly as the last one. So again, I'm going to take the cube root of x cubed, or x, cube root of 27, or 3. The trinomial on the right is that squared, x squared, that squared, which is 9. And in between, I'm going to have x times 3, or 3x. And in this string, the only minus sign I'm allowed is in the binomial at the beginning. This is factored. It's done. I can't go any farther. On the right, if I'm asked to solve, I set these factors now equal to 0. Could be x minus 3 is 0. In that case, x is 3. Or it could be on the right, this trinomial is equal to 0. You're going to find that can't be factored. So again, use the quadratic formula, and you will find, using the quadratic formula, that x is equal to -3 plus or minus 3i root 3 over 2. This would have been a perfectly fine answer to go with x equals 3 and you're done. Dots, remember, stands for difference of two squares. Quadratic form means it's similar to the difference of two squares. This is not a square. This is a quartic. This is a power of 4. But I could treat it like it's a perfect square. I could treat it like x squared minus 81. And if it were treated like x squared minus 81, well, remember, that would break down using difference of two squares as x minus 9 times x plus 9. And all I have to do from that point forward is reverse what I did to this power of 4. I had split it in half to make it x squared. So now I double it back again. So instead of it being x minus 9, it becomes x squared minus 9. Instead of x plus 9, it goes back to being x squared plus 9. That's finished. Oh, I'm sorry, no, it's not. X squared minus 9, you can factor farther, my mistake. And so you've got x plus 3x minus 3 times, this is finished, x squared plus 9. So on the right, now I've got those terms equal to 0. If x plus 3 is equal to 0, then x is negative 3. If x minus 3 is equal to 0, then x is 3. If x squared plus 9 is equal to 0, then x squared must be equal to negative 9. Well, if x squared is negative 9, then x has got to be plus or minus 3i. So you've got four answers. Minus 3, plus 3, 3i, minus 3i. Those are your four solutions to this question. Another dots question, again in quadratic form. This is very similar. Treat this like it's y squared minus 100. If that were y squared minus 100, then the factors would be y minus 10 times y plus 10. So I'm going to change them to y squared minus 10 times y squared plus 10. In this case, I am done. You can't go any farther because these are not difference of perfect squares, and that certainly isn't either. That's as far as I can go. Okay, so if y squared minus 10 times y squared plus 10 is equal to 0, then either y squared minus 10 is equal to 0 or the one on the right is. If y squared minus 10 is equal to 0, that means y squared is equal to 10. On the right side, I've got y squared is equal to negative 10. This means y is equal to plus or minus the square root of 10. The right side, though, means y is equal to plus or minus I times the square root of 10. And so again, you've got four answers. The plus or minuses, these two without I, those two with I. Okay, breaking the combination, remember, refers in our terminology to cross them up and split the middle. Quadratic form means I've got a polynomial that I don't know how to factor, but if it were a quadratic, I'd be able to. The quadratic form of this polynomial would be x squared plus x minus 6. If I'd had that, the factors of this, you should know, are x, well here, I'll just reveal it here, x plus 3 and x minus 2. And in the interest of time, I'm just going to quickly remind you that now I've got to build this back up. I've got to double that exponent over again on the x variable, so I've got x squared plus 3. And I've doubled this one as well. I've got x squared minus 2. Set those equal to 0. That means either x squared plus 3 is equal to 0 or the right side is. If x squared plus 3 is equal to 0, x squared is equal to negative 3. Whoops, might as well just do it this way. And the right side, x squared is equal to 2. If x squared is negative 3, x is plus or minus I root 3. On the right side, if x squared is equal to 2, then x is plus or minus root 2. I think I'm going to run out of time here, so I'm going to stop here, and unfortunately I'm going to have to finish the last couple of examples on another video.